In this video, we are going to be dealing extensively with factorization as a method of solving quadratic equations. Now, even if this is your first time of hearing about quadratic equation, by the end of this video, you're able to solve very difficult quadratic equations using the method of factorization. So, let's dive in. Here we see that factorization is a process of expressing a quadratic equation as a product of two simpler linear expressions. So, what does this mean? In our previous video, we mentioned that the general quadratic equation is denoted by this: ax squared plus bx plus c equal to 0. This is the general form of a quadratic equation. Now, what the method of factorization does is that this general form of quadratic equation is a polynomial of degree 2. So the idea of factorization is to break this down into linear factors, say rx plus b multiplying vx plus a equal to 0. So the idea of factorization is to write this expression, which is power 2, to linear factors. Linear factors means the highest power of the polynomial is 1, so that we can equate both of them to 0. That is basically what factorization of quadratic equation is all about. To write a polynomial, it may be polynomial of higher degrees, you bring it down to the simplest form it could be. That is the method of what factorization. So let's look into concrete example of factorization of quadratic equation. Now, if you have a quadratic equation like this, x squared minus 9x minus 10, and we want to factorize this, it basically means we should write this thing as a product of linear factors. That means this is the power of 2. The product of two factors, which highest degree of each of them is 1. So now, one thing you need to note about quadratic equation, one thing that's very, very vital is that this quadratic equation that is like this: ax squared plus bx plus c equal to 0. Right? This is the general form. Now, there is a general meaning for a quadratic equation, which is x squared minus sum of roots x plus product of roots. Now, I want you to note this in very well. This is the general meaning of a quadratic equation. Now, if you look at this thing now, if you want to write it in this form, you have x squared plus, that means you are dividing through by a, b over a x plus c over a equal to 0. Now, we are going to make use of this thing when we talk of nature of quadratic, that is this one here. But for the sake of factorization, just know that this is the general meaning of a quadratic expression. Now, this quadratic equation here now says this is x squared minus sum of roots. So in this case, now it's telling us that the sum of roots for this quadratic equation is 9. Are you following me? Yes. Now, minus 10. So it's telling this x here. It's telling us now that this minus 10 is the product of roots. So it's saying when we sum the root of this quadratic equation by this general meaning, when we sum the root, it is 9. Now look up, when you compare, see this negative sign, right? See it here. This 9 is what it is. So the sum of roots for here is what? 9. This is the sum of roots. Now the product of roots in this case is what? Minus 10, not 10. The product of roots here is minus 10 because this plus sign is plus here. Then there's a minus 10 in the bracket. So the product of roots here is what? Minus 10. Are you following me now? So how do we now factorize this? Now we now have the sum of roots and the product of roots. So from here now we see that the two numbers that we can add to get this, that's when we multiply, we get this are what? Minus 10 and 1. When we multiply these two, we get minus 10. When we add them, we get minus 9. So this quadratic equation now, we can now use those factors to replace this x so that nothing will change in our quadratic equation. What do I mean? We have x squared minus 10x plus x, which is 1x, minus 10 equal to 0. So this thing now, it means that we do not change anything. We just find a suitable number that can substitute for that minus 9x. When you sum these two together, you come back here. But the idea of factorization is that when you multiply those factors, you still get this one, which is the product of roots. So from here now, we can easily factorize them by putting them in this bracket this way. So when we factor out x from here, we have x bracket x minus 10, and here when we factor out 1, we have 1 times x minus 10. You see that this now looking as if x plus 1 is multiplying x minus 10. See that we have now written this thing now as a product of linear factors. That means we have factorized this quadratic equation. These are the factors. This linear factor multiplied by this linear factor will give us this quadratic. You can just pause the video and multiply these two things. You see that it's going to give you this. Now, what does this mean? If two numbers multiply each other to give you 0, it means that it is either this one is equal to 0 or this one is equal to 0. So we are going to equate them, both of them separately, to 0. So that x plus 1 equal to 0. That means x equal to what? Minus 1, because this one will cross over and become minus 1. So this one will say x minus 10 equal to 0. So that x equal to 10. So we see when the negative sign crosses, changing to positive. So we see that these are the roots now. The root of this quadratic equation now are what? Minus 1 and 10. So these are the roots of the quadratic. So if you see that if you sum up the roots now from that what we said earlier, the sum of the root now will give you what? 9. And the product of the root will give you minus 10. So these two are the solution for that quadratic equation. If you use these two solutions and put it in that x squared, you put it here, x squared minus sum of root x plus product of root equal to 0. You see that you get back the quadratic equation that you started with. So this is just how to solve a quadratic equation. So let's solve more problems of quadratic equation using factorization. Okay, so we are asked to factorize this particular quadratic equation, and I believe you know how to start by now. So we look for two numbers we are going to add together to get minus 1, because this is minus 1x. That's when we multiply them, we are going to get minus 20. So you can pause this video and do the solve. Now let me show you a trick of how to do this thing. The trick of how to do this is that, guys, how to get the factors. The easiest trick is this number here that you are multiplying, you find the multiples of it. Let's say like the factors of it. For let's say 20 now. 20, when 2 divide 20 you have 10, 2 divide it you have 5, 5 divide it you have 1. So that 20 is gotten by 2 times 2 times 5. So from these particular factors that can multiply to give you 20, to know the ones that are like that suits as the factors of this particular quadratic equation, whose constant term is 20, is that you can come and pair 2, say 2 and 2 times 5 is what? 10. When you check them, when you sum them, is there a way they can give you x? You say no. You now say 2 times this one is what? 4. So 4 times 5 is what? 20. Is there a way 4 times 5 can give you minus 1? Yes. When it's what? 4 plus minus 5. So that when you times them, 4 and minus 5, you get minus 20. When you add them, you get minus 1. So that 4 and 5 are the factors of this particular quadratic equation. So from here now we can proceed and say x squared minus 5x plus 4x minus 20 equal to 0. So from here now we see that we did not change anything from this our quadratic equation. Like when you sum these two, you still come back here. So we did not like introduce a new thing. We just adjusted it so that we're going to factorize it comfortably. I believe you are following me. Yes, thank you very much. Okay, so we go further by putting them into these brackets this way. So we can factor out x from here. So that x, you have x minus 5. Then when you factor out 4 here, now when you are doing this, you want to make two of them to be as if 2 linear factors are multiplying, because when 2 linear factors are multiplying, we have the values from one, we multiply the values from another one, the other one. So here we have x minus 5. So when you multiply this 4 inside this bracket, now you see that you come back here. But the idea is to make these two look alike, so that it will be as if x plus 4 is multiplying x minus 5. So this is actually what it is. You are just trying to do it this way because this is the route towards your solution. This is the best route to get to the solution you are looking for. So from here now we see that the same way we can easily equate this, because if the multiple of two things are 0, either this one is 0 or this one is 0. So we equate both of them to 0. So we have x plus 4 equal to 0. So that I have that x equal to minus 4. I will say that x minus 5 equal to 0. We have that x equal to 5. So if we bring this thing now, these two, they are the roots of the equation, right? If we bring this to now, express it as x minus x squared minus sum of roots is what? Minus 4 plus 5. This is the sum of the root x from that expression I gave, which I call the definition or the general meaning of a quadratic equation in my terms. So you see that we say plus product of root is what? Minus 4 times minus 5, which is equal to 0. You see that when you look at this thing now, you see that this x squared minus, this will give us what? 5, right? Okay, let me just write it here. We have x squared minus, so this one will give us what? 1x, because minus 4 plus 5 is 1. So here we have minus 4 times 5, which is what? Minus 20 equal to 0. So when you open this one, you have x squared minus x minus 20. See that these two are actually the solution. So this is actually how to verify the solution of the quadratic equation. Just put it into x squared minus sum of root x plus product of root. So I believe you are following. So let me give one example so that you meant what you have just learned, because I believe you have learned this with the way it has been explained. So let me give another example. Okay, so we have another example here before, and this one look a little bit different than the one we have seen before, because the value of a in this one now is now 2. Remember, the ones we did, the value of a are always they are 1. The two we solved, the value of a are both 1. So in this case now the value of a is 2. Now in case you have a question, any question, or there's something you don't understand, just feel free to put it in the comments below, and we are going to attend it to you as fast as possible. So thank you very much. So now when you have a quadratic equation like this, how do you approach it? Will you just say two numbers you multiply to get 5, and when you add them you get 3? No. Or will you say this quadratic equation cannot be solved? No. So when you have something like this, the way to approach it is you multiply these two parts now. So I'm having 10, right? Minus 10. So you look for two numbers that you multiply to give you minus 10, so that when you add them you get 3, minus 3. So this one is like, even let me say, more general, because those one we had 1. The reason we are not multiplying this product, this constant, is because when we multiply it, we still have 1 back. So but in this case now we don't have 1 here. So when we multiply here, we have what? Minus 10. So we look for the factors of this minus 10 or 10, and after we know how to fix the sign. So from this now we can see that the factor of this, the factor that satisfies this is what? 7 minus 5 and plus 2. When you times this thing, you are going to get what? Minus 10, right? When you add them, you are going to get minus 3. So these two are the factors that satisfy this particular quadratic equation. Now let me rephrase it. Let me say it again. When you have the coefficient of x is not, when you have the coefficient of x as not 1, what you are going to say is that coefficient of x times this constant term. Then you now look for the factor of that stuff. Then you look for two numbers out of those factors. There is two combinations, but when you add them, you are going to get this sum, because this one is the sum of roots, right? Then this one is the product of roots. So that is how to approach it. Exactly. Okay, so from this one now we have 2x squared minus 5x plus 2x minus 5 equals to 0, right? So we can easily put them this way and see what we have here. When we factor out x here, we have what? X bracket 2x minus 5. So when we factor out 1 here, we have 2x minus 5. So see that these two are looking at it, x plus 1 and 2x minus 5 equal to 0, and multiplying them, right? So as usual, you equate both sides to 0, because you already know the reason. X plus 1 equal to 0, so that x equal to what? Minus 1. So we have 2x minus 5 equal to 0, so that 2x equal to 5, right? So divide by 2, divide by 2. So that the value of x equal to minus 1 or 5 over 2. So this is how to solve something like this. So I'm going to give you one so that you try it out and put the answer in the comment below. It's very, very simple. Okay, it's very simple. Thank you very much for your understanding. Okay, so we just have just one classwork for you. Yeah, I want you to solve this particular quadratic equation by method of factorization and put the answer in the comment below. I'll be very, very happy to see your answer. And if you happen to attempt it and you don't get it correctly, I'm going to teach you how to solve it. Okay, so thank you very much. Now, does it mean every quadratic equation can be factorized? Is it possible to factorize every quadratic equation? Now let's quickly look into this particular quadratic equation. Okay, now we have a quadratic equation like this. Can this quadratic equation actually be factorized? Are there two numbers that when we add them, we're going to get 4? And when we multiply them, we're going to get 2. Is that possible? No. This quadratic equation cannot be factorized. That's why in the previous video we saw the almighty formula. The almighty formula can be used to solve quadratic equation like this. But how do you know that a quadratic equation cannot be factorized even without solving anything? Like, how do I know that this quadratic equation cannot be factorized? Now, we know by a very special tool from the quadratic formula which we know as the discriminant. So in this video here, we talk extensively about the discriminant and how to know a quadratic equation that can be factorized and the nature of how the roots can be, whether you get a real root, whether you get a complex root, whether you get same roots. So I'll see you in that video. Thank you very much for watching. Subscribe.